So, what do you got for me tonight? Okay. Right. It is theta that you're talking about, okay? All right. If I'm going left to right, or excuse me, I'm going counterclockwise that way, angles are positive. Okay? That's pi over 2, that's pi, that's 3 pi over 2, and that's back to 0. If I'm going this way, angles are negative. So this first one would be actually minus pi over 2. In other words, 3 pi over 2 is, let me correct that. That would just be a smudge. 3 pi over 2 is the same as minus pi over 2. You see why? Because it's 90 degrees. In other words, if I'm starting at the 0 line and going clockwise, which is what negative angles do, then I'm going to get, if I just go to minus pi over 2, I'm going to be right there at that spot. So, is minus 2 pi over 3, where is that? And the angle, the quadrants don't change. They're always going to be numbered counterclockwise, like that. So where is minus 2 pi over 3 put me? Actually, it's quadrant 3. And here's why. This angle right here is minus pi over 2. Remember, pi over 2 is 90 degrees. Okay? 2 pi over 3, if I were to go all the way to this angle, what's that? No, it's 180 degrees. That's pi, so that would be minus pi. Okay? Now, if I look at minus pi over 2 and minus pi, 3 pi, or minus 2 pi over 3, the angle you have given me, is between those two. Okay, let's look at it on a number line. Okay, here's 0. Now there's minus pi over 2. Here's minus pi, correct? Twice as far. Well, minus 2 pi over 3 falls in this range right here. It's not as big a number as minus pi. It's only minus 2/3 pi. So it doesn't go all the way to the minus pi, but it's greater. I don't know if greater than is the proper word. Mathematically, it's actually less than minus pi over 2. Okay, but it definitely falls in this part, and that's the third quadrant. If I'm going to label these quadrants, that's the fourth quadrant, right? From 0 to minus pi over 2 is the fourth quadrant. You see that? Okay. If I want to get to the second quadrant, it would be numbers like minus 5 pi over 4. In other words, numbers to the left on the line graph. So it kind of goes like that when you're going clockwise. If I'm going counterclockwise, then that's pi over 2. That's first quadrant. And then I go to pi, that's second quadrant. Then I go to 3 pi over 2, that's third quadrant. And then I go to 2 pi, and that's fourth quadrant. So you can see the direction actually goes the same regardless of which way you're going. It goes 1, 2, 3, 4 when you go from left to right. Regardless of how far left I go and how far right I go. I'm just going to number these 1, 2, 3, 4, and going backwards, it's 4, 3, 2, 1 if I'm going to the left. Okay, so hopefully that'll give you a little bit of help in doing these. Give me the next one. Okay, what they mean by that is that there's the terminal side right there, okay? Starting from there. What is the sine of the tangent in the third quadrant is what they're asking. Correct. All students take, T is for tangent, calculus. That's all you had to know. That's all you had to know to answer that question. What is the sine of the tangent? They don't mean SIN, they mean SIGN. Is it plus or minus? Is the sine plus or minus for the tangent in the third quadrant? Okay? Okay. What is it? Correct. In other words, we use this acronym, all students take calculus, because if I write it correctly, it's really this. Sine and cosecant are positive in the second quadrant. If I write this one, it's tangent and cotangent. Because after all, cotangent is the reciprocal of tangent, right? So if I have a number that is plus or minus, its reciprocal is also going to be plus or minus. And cosine is actually cosine, and what's its reciprocal? Trig function? Well, it's secant. In other words, secant is the reciprocal of cosine. Let's talk about that for a second, because this is the first night we've talked about these secant functions. Okay? You have the first three that they teach you. Sine, cosine, and tangent. Right? And then there's those other three. Cotangent, secant, and cosecant, that represent the reciprocals of each of these. And you just have to figure out which one goes with which. Well, you always know what goes with tangent. What goes with tangent? What's the reciprocal of tangent? Cotangent. Okay? So start there, which only leaves two to be allocated. One of them goes with sine, one of them goes with cosine. Between the secant and the cosecant, which one goes with sine? Always the different letter. Never the same letter. In other words, if I put secant with sine, I'd have the same starting letter. Both of them start with S. So that does not happen. So what goes with cosine? That's the way I always use, that's what I use to memorize, is those first two letters have to be different. And then you can't get it wrong. Okay? So, let's go back to your problems. What's the next one? Okay. So, what two quadrants is cotangent greater than 0? Well, which one for sure are all 6 trig functions positive? No, the first one. That's what the A stands for. All students take calculus. Okay, the A stands for all. So cotangent is positive in which 2? Every trig function is positive in 2 out of the 4 quadrants. Okay? Which 2? So cotangent is positive in which 2 quadrants? Number 1, for sure. Right. Cosine is negative in which 2 quadrants? By number. Okay? Okay. Now, take the common one between those 2, and that will narrow it down to only 1 quadrant. There's only 1 quadrant where the cotangent's positive and the cosine is negative. Yeah. Here's one way I might write that. So cotangent is positive there and there, and cosine is negative here and here. And they're telling you, where do both of those occur? Well, there's only one that has the green and the blue. It's quadrant 3. Okay. What else? Okay. Okay, those both say the same thing. In other words, you've merely given me a radian angle instead of a degree angle. Okay? So, we're looking at cotangent. So where would cotangent not be defined? What makes something not defined? What's the one thing in math that makes something not defined? Division by 0. Yeah, because division by 0 causes infinity. If you take any number and divide it by 0, you're going to be looking at infinity. Maybe negative infinity, maybe positive infinity, but that's what undefined means. Okay? So we have to find a place, not where cotangent is 0, but what? What's the reciprocal of cotangent? Yeah, so we're looking for where tangent equals what? 0. Yeah, if tangent equals 0, and the reciprocal of 0 is division by 0. So when they say where is cotangent undefined, is the same thing as asking where is tangent equal to 0. Okay? Now, tangent is equal to 0 because tangent of theta equals the sine of theta divided by the cosine of theta. That's a key identity. You want to lock that in your memory banks. Okay? So what's going to make tangent of theta equal to 0? If it's equal to sine over cosine, which one is going to have to be 0? Is it the sine or the cosine? No, don't get the two things mixed up here. In other words, we're trying to figure out where cotangent is undefined, and we know that's where tangent is 0. Okay? If tangent's equal to sine over cosine, how can that be 0? If I say 0 equals sine of theta over cosine of theta, what has to be true? No, sine of theta has to be 0. If sine of theta is equal to a number, well then this whole thing cannot be equal to 0. The only way something can be equal to 0 is if the numerator is equal to 0. Okay? In other words, if I say 0 equals this, well, let's solve it algebraically. Let's multiply both sides by cosine of theta, which gives you 0 equals sine theta. So what we're looking for is this. In other words, we started with the cotangent being undefined, okay? For the cotangent to be undefined, its reciprocal has to be 0. Its reciprocal is tangent. So tangent has to be 0. And tangent is only equal to 0 when sine theta equals 0. So we can do this two ways. Let's start drawing the graph. There's sine theta. Where is sine theta equal to 0? This is the x-axis, this is the theta axis, this is the sine theta axis. So where is the vertical part equal to 0? When theta is what? Well, how about there, for starters? When theta equals 0, sine theta equals 0. Also, at pi, sine of pi equals 0. And also at 2 pi, sine of 2 pi equals 0. But most likely, when you gave me this domain up here, it was not less than or equal to 2 pi. I'm guessing that I wrote it wrong. It was just less than 2 pi. And greater than or equal to 0, right? In other words, the top one is really what they mean. That one right there. They mean theta is greater than or equal to 0 and less than 360 degrees. So if I'm answering their question which two answers do I have to give? Not three, but just two. Zero and pi. 0 and pi are the answer to this question. When theta is 0 or pi, cotangent is undefined. And we had to go through all these steps to figure that out. We had to figure out, well, where is it undefined? It's undefined when tangent is equal to 0. And where is tangent equal to 0? It's when sine is equal to 0. Okay. Okay. What they mean by the reference angle, this is the way they teach it in school. It's not particularly the way I teach it. You'll notice when I did that one-day session with you where I had the unit circle and I said take a picture of that, I didn't use reference angles. You know what I used? These. That is the same thing as the reference angle. That's why I had you memorize those. If you're in the first, second, third, or fourth quadrant, you figure out the reference angle by doing this. Now, if you are in radians, these change a little bit. Let me write them in radians. Instead of 180, what is it? I'm going to be in radians. It's pi. It's pi. So what's the third quadrant one? And what's the fourth quadrant one? You got it. Now, it's really easy now. So substitute that for theta. So all you have to do is figure out which quadrant it's in. So let me label the quadrants in terms of radians. So which quadrant is this one in? This is not, yeah, it is in the third. It's, how can I put this? What you're doing is trying to compare 7 pi over 5 to whether that's greater than or less than 3 pi over 2, right? In other words, if it's less than 3 pi over 2, it's in the third quadrant. If it's greater than, it's in the fourth quadrant, correct? So let's compare these. What's a common denominator that we can do? In order to truly compare them, we want the same common denominator. What common denominator are we going to use? Okay. So what's the numerator on this one? If the denominator is 10. About 14 pi. 10 is twice 5, so the numerator has to be twice. All I'm doing is multiplying top and bottom by 2 to get this bottom number, okay? Now, on the second number, multiply top and bottom by 5. What do you get? 15 pi over 10. Now, it's easy to compare now. Which one's bigger? Three pi over 2 is bigger. Because I've got the same denominator, and now all I have to do is compare the numerators. So that's in the third quadrant. That's the first step, figuring out what quadrant it's in. And now you know which formula to use, right? Which one? Okay. So what do you get for, oh, did they just ask, oh no, they wanted the reference angle. So what is 7 pi over 5 minus pi? In other words, apply that formula that's in the third quadrant. What do you get? 7 pi over 5 minus pi. Well, how do you do that math? Again, you need a common denominator. Okay, which means I gotta have that there. 5 pi over 5 is the same as pi, right? So what's the answer? That's the correct answer. Now, what is the reference angle? Well, let's draw that angle somewhere close to that. So that big blue thing is 7 pi over 5, right? The reference angle is the angle it makes with the x-axis. That's called the reference angle right there. This smaller amount. Okay? So that smaller blue arc is what is 2 pi over 5. That is 2 pi over 5. That is the reference angle. And these equations that I put in quadrant 2, 3, and 4 give you precisely the reference angle. What I always call what is the equivalent first quadrant angle is the way I have referred to the reference angle. I personally think the reference angle is more complicated than is needed. So I tend to leave it out of my teaching because it does confuse students pretty easily. And if you just use these formulas, you can always convert any angle, which is in any quadrant, to the equivalent first quadrant or the reference angle. Same thing. They all mean the same thing. All right. I'm going to leave my unit circle up there. I got a feeling you got a similar problem coming up, just a different angle. Different? Okay, let me erase everything. Go ahead. Seven pi over 10? Okay. Right. So if we were in degrees, we find coterminal angles by adding or subtracting multiples of 360. Okay. So let's go look at one that's in degrees, just for practice before we tackle this. Okay. Give me a coterminal angle to that, what I just circled, a positive one. Give me a positive angle that's coterminal to 300 degrees. What is it? What are you going to do? You're going to add 360, right? What do you get? There's a positive angle that's coterminal to 300. Now give me a negative angle that's coterminal to 300. What are you going to do? Okay. That's how you do these. Okay? Now, the problem that they gave you is 7 pi over 10. It's in radians, so instead of adding 360 or subtracting 360, what are we going to add or subtract? Not 360, but what? How many radians? 2 pi. 2 pi, which is 20 pi over 10. Yeah. In other words, you should know that you're starting with 2 pi. That's the key number, okay? Now, you need a common denominator to add these two things together. So we multiply the bottom by 10 to give us a common denominator, multiply the top by 10 to give us a common. Now 20 pi over 10 is the same as 2 pi. And we can add these two fractions. What are they? That's your positive coterminal angle. And now what is your negative coterminal angle? Yeah. Over 10. Not 13 pi. Don't forget to bring the 10 forward. Okay? That's a negative angle in the unit circle, and that's a positive angle outside the unit circle. Because the angle they gave you was in the unit circle, if I add 2 pi to it, I'm always going to be outside the unit circle, and if I subtract 2 pi from it, I'm always going to have a negative angle. As long as I start with an angle that's in the unit circle. If I start with an angle that's in negative, then I have to add 2 pi to it to give me a coterminal angle, and I have to subtract 2 pi to it to get it to stay negative. So if you have any of those, what do you got next? I'm sorry, what? What did you say? Oh, evaluating. Go ahead. Okay. What you need to be able to answer these is have that page memorized. That I asked you to memorize. Okay, so first of all, always ask what quadrant it's in. Okay, I'm going to put a 2 over it, and I recommend you do the same thing when you're doing these. Okay, what is what I used to call the equivalent first quadrant angle, but what I'm now going to call, what is the reference angle? Apply the formula, and from the second quadrant minus this, what is it? Let's stay in degrees. .45 degrees is the reference angle. Now, what is the tangent of 45? Now you have to revisit those two triangles, unless you have it memorized. It's a good one to memorize. This and the sine of 30 are really good ones to memorize, because all of these are good to memorize from the first quadrant, because you have to use them all the time. I mean, all the time. Every time we have a session, you have to use it about 100 times. So memorizing them would be far easier than going back and drawing those two triangles and reading them off of the triangles. So 45 is 1. Okay? Now there's one last step. And every single evaluation is these same 3 steps. You figure out what quadrant it's in, you figure out the reference angle, you figure out the answer to that, and then you put on the plus or minus sign. What is tangent in the second quadrant? Okay, that's the answer. Here's the ones you want to really know. Sine of 30 is 1/2. Sine of 60 is square root of 3 over 2. And sine of 45 is square root of 2 over 2, if you like, or 1 over square root of 2. Okay? So those three, just kind of memorize them, and then you don't have to constantly go back to that triangle and figure them out. And notice cosine is very similar. Cosine of 30 is square root of 3 over 2. Cosine of 60 is 1/2. And cosine of 45 is your root 2 over 2. You want to have those on the tip of your tongue. You don't want to have to take 15 seconds to figure out what the sine of 60 degrees is. You want to know what it is, like you know the back of your hand. Okay? Only because you have to do it so frequently. Every single angle they're going to give you here, we're going to have to do that. So, what's the next one you have? Okay. Well, they're mixing it up, aren't they? Let me erase that top one just so we'll have room to write above it. Now, the way I do these secant, cosecant, and cotangents are I figure out what the sine is and just flip it. That's what I do. I don't think in cosecant, secant, and cotangent terms. I never do. Somebody asks me what one of those three trig functions is of an angle, I figure out what sine or cosine or tangent is of that, and then I flip the answer. That's all you have to do. In other words, you really have to only know three trig functions and just know which one goes with the other one. You know, which one is the reciprocal of cosecant? Yeah. So, we're going to turn it into a sine problem. We're going to figure out what the sine of 5 pi over 3 is. And then we're going to take whatever that answer is and flip it. Just invert it. And that's what the cosecant of 5 pi over 3 is going to be. Always. You can just do that with any of them. They're talking secant, figure out what the cosine is, flip it. They're talking cotangent, figure out what the tangent is, and flip it. Okay? So, first step, to figure out the sine. Not yet. Now let's make sure we do these in order. You have to figure out what quadrant it's in. That's why I want you to do it the same way I'm doing it here. And I want you to do it, when you do it on paper, do it step by step by step. In other words, first, convert that cosecant to sine. That's step one. Step two, what quadrant is it in? Yeah. And put a 4 over that. Let's circle it. I'm in the fourth quadrant. Therefore, what is its reference angle? Okay. What is 2 pi minus 5 pi over 3? No. 2 pi is bigger than 5 pi over 3. 2 pi is 6 pi over 3, right? So it's 2 pi minus 5 pi over 3. 2 pi, that's the equation we're using, minus 5 pi over 3. How do you do that? You got to be able to do these on your own. Okay, do it. Okay. So what does 2 pi become? What does 2 pi become? Okay, so it's 6 pi over 3. Now you can subtract them. What do you get? Okay, so that's our reference angle. I'm going to write it in blue, in parentheses, right next to the theta they gave us. Okay, now, what's the sine of pi over 3, which is also 60 degrees? Hold on, it's not negative yet. Don't figure out the sine first. I want you to do it in the order that I do it. So figure out the number first. That's why we got the reference angle. Because we know what that number is. What is the sine of 60 degrees? Okay. Now put the plus or minus sign on it. It's in the fourth quadrant, so what is sine? Okay, so that's what the sine is equal to. But they want to know the cosecant. So what's the cosecant equal to? That's why they don't want you rationalizing it. Because you can see that when you're looking at the reciprocal, if you've rationalized it, it makes it worse when you look at the reciprocal function. So that's the answer right there. Now, has your teacher mentioned this rationalization concern? That hadn't said anything about it? Does he have you rationalize everything? There are some teachers, I mean, 5 years ago when I was tutoring, most teachers had you rationalize everything. It's only been in the last few years that they finally have all gone to church or something, but they don't rationalize the stuff now, as they shouldn't in trig. So this is the answer. Minus 2. Now, if I was going to rationalize that, what would the answer be? Just so you know how to rationalize. In case your teacher really does have you rationalize it, he would want you to rationalize that because it's got an irrational denominator. So how do you rationalize that? How do you do that? Nope. You can only multiply a fraction by the number 1. You can't multiply it by anything else. If you multiply a fraction by something other than 1, you're changing its value. But you can always multiply it by 1 without changing its value. Well, what's another way of writing 1? Root 3 over root 3 is also the number 1. In other words, I can multiply that fraction by root 3 over root 3 without changing its value. And what it does is rationalizes the bottom. What's the bottom become? What's root 3 times root 3? Nope, it's 3. Root 2 times root 2 is 2. Root 17 times root 17 is 17. Okay, what's the numerator? No, when you're multiplying that, it just becomes 2 times root 3. with the negative sign carrying forward. So this is a rationalized answer that is exactly equal to that. The only time you would use this, maybe it's a multiple choice test, and this answer is not on there, but this one is, they're the same number. So you'd have to be able to recognize that. If it's not a multiple choice test and you're always having to write the answers, then it's probably something you don't have to concern yourself with, this rationalization thing. But the thing about trig is you very, very frequently have irrational numbers in the denominator on these common angles. You always have a square root of 3 or a square root of 2 involved in most of these trig functions. So if it's in the denominator, it's not rationalized, which is fine. Unless they give you the rationalized answer. So you really need to know what rationalization is and what it does and what the, how to rationalize it if you need to. Do you ever have your tests, or are they multiple choice? Are your tests multiple choice? They are? Well, then you definitely need to know about rationalization, because they could put the answer might be rationalized, might not be. So you got to be able to know how to rationalize it. All right, what's another one? Okay. Mm-hmm. Okay. How far would the wheels travel if we were to rotate them by 2 pi radian? In other words, 1 full revolution is 2 pi radians. No, it'd be the circumference of that circle. That's how far the wheels travel. In other words, if I take a wheel here, it's got a diameter of 36 inches, and I start rotating it to the right, after 1 complete revolution, the distance it has traveled from there to there is the circumference of that circle. Right? In other words, this point that's on the pavement right there, it's going to start moving in this direction, right? By the time it gets back to the exact same point on the ground, we have moved 1 circumference of the circle. So what's the circumference of this circle? What's the circumference of a circle? What's the equation for the circumference? Two pi r. Okay, yeah, you can't forget all your equations from geometry. You're going to need them in trig. So the circumference of the circle is what here with this particular wheel in inches? Times it's the radius of this wheel. Okay, so 2 times that's 36. So 36 pi is the circumference of the wheel. And that is the distance it would travel if the wheel made one revolution. It would be 36 pi inches. Okay? So if you rotate the wheel by 1 radian, how far does it travel? Instead of 2 pi radians. Now, what's the relationship between 1 radian and 2 pi radians? Let me ask another question. You'll get this if I keep asking you these questions. How far would the wheel travel if you rotated it by pi radians instead of 2 pi? We know how far it'll go if we rotate it by 2 pi radians, right? 2 pi radians is 1 full revolution. So if the wheel makes a half a revolution, how far is it going to go? Okay, now you're catching on. So what is 1 radian compared to pi radians? Or let's go back to the original problem. 1 radian is to 2 pi radians like that. It's 1 over the number 2 pi. Well, 2 pi is about 6.28, right? So what I'm looking for is the fraction. In other words, what is this fraction? If I had 2 pi over 2 pi, I'd have a fraction of 1. And we already know that it goes a complete 36 pi distance. 36 pi inches. So it's going to go about 1/6 of that, right? I'm going to actually take that answer and multiply it by 1 over 2 pi. That's the fraction that we're multiplying it by. 1 radian compared to 2 pi radians. Because I know with 2 pi radians, it goes 36 pi inches. So if I want to know how many inches it goes with 1 radian, I'm going to multiply by that fraction. Notice how nicely the pi's get rid of, and I go 18 inches. If I'm only turning 1 radian. Now, let's talk about radians for just a moment here. One radian is about that. Okay? This angle right here is about 1 radian. Notice that it's only about 1/6 of what it would take me to go all the way around the circle. 2 pi distance, or 360 degrees. Okay? Now, why is that angle 1 radian? Because that is the precise angle where the radius equals the length of that arc. So if I have a radius of 18 inches, then 1 radian cuts out an arc of 1 radius. And that's an important definition to kind of keep in the back of your mind always. That's what a radian is. It's an angle where the arc that is cut out is equal precisely to 1 radius. Whatever the radius is. If the radius is 2 inches, then it would cut out an arc of 2 inches. If the radius is 18 inches, then it would cut out an arc of 18 inches. But 1 radian is about 57 degrees. About, if you round it off. Okay? So this ratio up here is 1 radian compared to 2 pi radians. In other words, 57 degrees compared to 360 degrees. So it's about 1/6. Okay, what's another question they have besides how many inches it'll go with 1 radian turn? we answered that already. How far did it go? 36 pi. Where'd you get 68? Okay. The first thing we did was figure out how far it was going to go in one full revolution. Okay. Now, this thing makes 630 full revolutions per minute. So this thing's going to be moving. It's going pretty fast. In other words, it's going to go 36 pi times 630, that total amount of inches every minute. Because it's going to make 630 revolutions in 1 minute, which means it's going to go 2 pi times 630. Okay, what else? So far, we haven't needed that number, so they must have a question coming that involves that number. Notice we did not need that number at all to figure out how far it goes in one revolution. What we needed was the radius. Third question for this problem. We got just enough time to do it if you want to give it to me. Okay. The trick on this particular question is getting your units right. Okay, it's all about getting the units right. So let me erase this, this, and this. From those two pieces of information, I can do this. Okay? So I want the answer to be in miles per hour, right? Well, right now I got it in inches. Let me move it over a little bit because there's a lot of steps here. So I got 630 revolutions per minute. Well, let's take the two most important conversions, which is 2 pi radians per revolution. Agreed? Notice that gets rid of revolutions. We have 18 inches per, here, let me write inches down here. We have 18 inches per radian. Remember, the radian is defined as being the radius. That gets rid of the radians. In other words, that's the way you do these. You just try to get rid of everything and end up in miles per hour. Well, I'm in inches per minute, so it's not that hard to convert to miles per hour. Okay, we know that there are 12 inches in 1 foot, right? Gets rid of the inches. There are 5,280 feet per mile. 1 mile is 5,280 feet. Gets rid of the feet. Now we're in miles per minute. Got to change it to miles per hour. Well, how many minutes are in an hour? 60 minutes per hour, right? Notice that gets rid of the minutes. Minutes and minutes. The only thing we have left are miles per hour. And the number is going to be 630 times 2 pi times 18 divided by 12 times 5,280. The numerator has one more multiplier, that number right there. So whatever that comes out to be is your answer in miles per hour. Okay? And this problem is always about the units. The tricky part is these two steps right there. It's not hard to convert minutes to hours or inches to miles, but it is a little tricky converting revolutions to radians or inches. Notice after we apply those two factors, we actually end up in inches per minute at that point. And that's what you want to get, is you want to get rid of the radians. And it's a little tricky. You have to remember that 1 radian is equal to 1 radius when you have a wheel problem like this. Wheel, not real. Okay? So these two steps are the two hardest steps for students to figure out. Right? Just put the 2 check marks. Once you get those 2 steps, you're good to go. The rest is just converting minutes and inches to miles per hour, or inches per minute into miles per hour, which is relatively easy. Those two, you just have to know the conversion factor, and you have to know which one needs to be in the numerator and which one needs to be in the denominator. Notice that if you're trying to get rid of something like minutes, then I got to have minutes in the numerator. So it's got to be 60 minutes per 1 hour. I can't have 1 hour per 60 minutes. I'm not getting rid of minutes if I do that. So you always put these conversion factors in the right order, numerator and denominator, to get rid of the units. That's the way you think about it. Whatever order is needed. In other words, 18 inches per radian, it's also 1 radian per 18 inches. So you have to know which way to apply it. Okay? Brandon, I'm going to let you go. I'll talk to you next time. Bye-bye.